Okay students, so you know that last class I have told you about the hardness of water. Okay, now what is hardness of water? What is hardness of water? Can you define it? What is hardness of water? It is a part of the chapter that is hydrogen. Do you know what is hardness? Not known. So hardness is that presence of some cations and anion in water sample. Presence of some cation and anion in water sample, due to which the quality of the water is harmful sometimes to the human being, and for this reason this is called hard water. Now, what are the cations and anions? Basically the calcium, magnesium with its chloride and sulfate. Generally calcium, magnesium with its chloride and sulfate, if present in water sample, then it is called as the hard water. Okay. Now the more important is that removal of hardness. That is, what are the, how many types of hardness is there? Can you tell me how many types of hardness? Yes or no? Do you know how many types of hardness is there? So hardness of water, it is of two types: temporary hardness and permanent hardness. I have told you in the last class about this. Temporary hardness is due to the presence of bicarbonates of the salts, and it is due to the presence of chlorides and sulfates. Okay. Now temporary, I have titled that hardness of water and its removal. Now the removal, temporary hardness is removal by boiling plus filter. So what is the chemical reaction? Bicarbonate. Suppose calcium bicarbonate is there. When we heat the substances, that is the water sample, it produces calcium carbonate, CO2 plus H2O. Okay. Now calcium carbonate is insoluble in water. Insoluble in water. So as it is insoluble in water, so we can easily separate it by using filter paper. That is the filtration method. So what are the process? One is boiling first step, second one is filtration. It is the one case. Next one is that by using slake lime. By using slake lime. So if calcium bicarbonate is present, and if we add calcium hydroxide to this medium, then it will produce CaCO3 plus H2O. So again calcium bicarbonate is insoluble. So one method, that is by boiling, second method by the reaction with slake lime. These two process is the removal of temporary hardness. Remember it, temporary hardness. So you may have question that describe about one method or write about one method to remove the temporary hardness. So what is, yes, I am repeating from the first. Today's topic is that hardness of water and its removal. I have discussed on the last class also about this. I am just touching the points. So temporary hardness, it is due to the presence of bicarbonate salts, because bicarbonates are soluble in water. So first of all you have to think about what is the preference of insolubility. If a substance is insoluble in water, then we can separate out it by using filtration method. It is one of the separation techniques also. Okay. So bicarbonate when present in water sample, the sample contains the temporary hardness. Now the methods to separate the bicarbonate from water sample or to make the temporary hard water to the soft water, the process is two. One is boiling and filter, and second one is reactions with slake lime. So first one is boiling plus filter. So when we boil it, that means we heated the substance, then the substance breaks down to produce CaCO3, calcium carbonate, carbon dioxide and water. Now CaCO3, it is insoluble in water. So as it is insoluble in water and our medium is water medium, okay, so using the filter paper or filtration method, we can separate out calcium carbonate. CO2 is gaseous form, it will be evolved from the system. Okay, so here one method is the removal of bicarbonate. Second method is that calcium bicarbonate have to treat with slake lime, that is calcium hydroxide, so that it can produce calcium carbonate and H2O. Again calcium carbonate is insoluble, and then we can separate out it by using filtration method. So these are the two methods by which we can separate out the temporary hardness method. Okay. Any question up to this? Next I will move to the permanent hardness. Now understood? Reply fast. Okay. Now move to the permanent hardness. Now just follow here. I have written the anion present in the permanent hard water, that is chlorides and sulfate. Okay. Now what are, there should be one opponent to that. What are the opponent? That is magnesium, calcium. These are the cations will be present there. Okay. So second point is that removal of permanent hardness. So first method of removal of permanent hardness, removal of permanent hardness, removal of permanent hardness method. Number one, reaction with soda or washing soda. Do you know the formula for washing soda? Very simple. Can you tell me the formula of washing soda? Second one is ion exchange method. And third one is Calgon method. Just follow that. Reaction with soda or washing soda. Second one is ion exchange method, and third one is Calgon method. Now we have to discuss one by one. Okay. So these are the process to remove the cations and anions present in any permanent hard water. Okay. So, first reaction, that is reaction with soda. Now, I have told you what are the cations anion present, that is calcium chloride, magnesium sulfate, also maybe magnesium chloride, etc. Okay. So, these are the compounds may present in the water sample. Now, assuming any one of these, I will treat the separation technique, removal. So, first one, just take calcium chloride is present. Now, washing soda having Na2CO3, the formula of Na2CO3. Now, it will produce twice of NaCl plus calcium carbonate. Now, again it is insoluble in water. So, we can separate the insoluble part by filtration. Okay. So, first one, reactions with washing soda and then filtration. So, how the cations are removed, that means calcium make combination with carbonate and this was insoluble in water. So, we can separate out the calcium ion, and the chlorine remains in the solution, it makes combination with sodium ion. Okay. Right? Clear? If any other salt, suppose magnesium chloride was present, then it will produce the magnesium carbonate and magnesium chloride plus Na2CO3, then it will produce magnesium carbonate plus twice of NaCl. Again the same type of reaction. If magnesium sulfate is present, plus sodium carbonate, again it will form sodium sulfate which is soluble in water and magnesium carbonate which is insoluble in water. So, again we can separate out this. So, this is the first method for the removal of removal of permanent hardness by washing soda method. Clear? Respond quickly. Next, number 2, ion exchange method. Ion exchange method. Now, first of all, describe about ion exchange method. Now, we have seen that it is due to the presence of some cations and anions. Okay. Now, if we exchange these cations and anions by using any other external substances, if we can exchange the cations and anions by using some other external substances, so that the water becomes soft in nature. Okay. So, in this method, ion exchange method, here we should use, one is cationic exchanger, which will exchange the cation, and anionic exchanger. Now, cationic exchanger, it is also called inorganic Parmutit method, and this is organic synthetic resin method. So, first one is cationic exchanger, it is also called inorganic exchanger and Parmutit method, and second one, that is organic or synthetic resin method. Okay. Now, what is Parmutit? So, ion exchange by 1 and 2. One is cationic exchanger, it will only exchange the cation, and second one is anionic exchanger. Okay. So, first move to the inorganic ion exchanger or cationic exchanger. Now, what is permutate? Permutate is sodium alumino silicate hydrate. Sodium aluminosilicate, the formula is Na2Al2Si2OH H2O. Hydrated sodium aluminosilicate is called the permutate, and the general name is formula is that Na2Z. So, Z is that part, Z is called zeolite. Z is zeolite. Okay. Now, from this formula, the sodium ion, this ion will be replaced in presence of calcium or magnesium. Okay. Okay. So, just follow the reaction. Suppose any calcium is present in water sample, Na2Z, it will produce CaZ plus Na plus. Okay, and as it is class cation, so it will make soluble in the aqueous medium. So, in this way the calcium from salt from the water will be exchanged by sodium. If magnesium is present, then again the same kind of reaction, Na2Z, it will produce plus 2Na plus. So, it is the calcium and magnesium make a complex compound with the zeolite, and sodium ion becomes free. This is the permutate method. Now, there is a pictorial diagram how permutate method is useful for the removal. This part is permutate. These are the pebbles. Through this pipe, the hard water there is the tap, here it is soft water, and a tube is there to charge sodium chloride. Okay. Now, this is the pictorial diagram. The hard water is passed by the tube and come at the bottom of the chamber. There is the pebbles to separate the large impurities. Second one, it will move to the with the permutate method where the cation exchange takes place, and above that layer it is the soft water, and by this tap we will get the soft water. Now, what is the role of sodium chloride? It is called as it is used to recharge the permuted. It is used to recharge the permuted. How it is recharged? For example, if in a limited, because you can see that in the diagram there is a limited amount of permutides were taken. Okay. Now, when the sodium ions are exchanging with the calcium and magnesium and make a compound with calcium zeolite or magnesium zeolite, then after certain time what happens, the activity of the permuted will be lost, and for this reason it have to be recharged. And how it will be recharged? So you have to use a aqueous solution of sodium chloride, so for as a supply of Na plus, to give a supply of Na plus to the permuted, so that the Na2Z form comes again, but Ca2 plus Z is eliminated. Okay. So this is called the regeneration or charging of the permuted. So for this reason NaCl is used. Okay. It is the permuted method. Third one is the resin method. What is resin? Now resin is of, it may be formed organically, that is by nature. In different plants you can see the resin. It is a hard substances, and it can also be produced synthetically. Now in the separation of or in the preparation of soft water from hard water, we will use the synthetic resin method. Next one is synthetic resin method. Now synthetic resin method are of two types. One is cationic exchanger. It is cationic exchanger, and another one is OH minus resin. It is anionic exchanger. Now when a hard water is passed by one cationic resin and then after an anionic resin, then both the cations and anions present in the hard water will be exchanged with the H plus and OH minus ion. What happens? If the hard water is passed by one cationic exchanger and then by one anionic exchanger, then in the first case the cation present in the hard water will be exchanged by H plus, which is no longer hard, and in the second case the OH minus ion will exchange the anion, which is no longer hard. So ultimately we get the soft water, and for this there two compartments are there. One is packed with the cationic exchanger and the anionic exchanger is there. From there hard water is passed by, and there is this hard water is passed by the second compartment, and at last we will get the hard water. And as it is producing by there is no cations and anions are present, so it is also called demineralized water. So demineralized water we will get by synthetic resin method or exchanging both the cations and anions. Okay. So this is ion exchange method. Next one is that regeneration of resin. Now we have to follow the reaction. Suppose calcium 2 plus is present. Suppose calcium chloride is present. CaCl2 is present. Now we have to remove both cations and anions. So Ca2 plus, when it reacts with H plus resin, the H plus will exchange, that is H plus plus Ca resin complex, and Cl minus, 2Cl minus, it will react with OH minus resin, that is anionic resin, forming Cl resin complex plus OH minus. Okay. So H plus and OH minus and the calcium or chlorine are trapped by the resin. Okay. So for this reason it is also called the demineralized water. So this is the reason. Next one is the regeneration or recharging of resin. Now here you can see that a certain amount of resins were taken. So after certain time the activity will be lost, because by exchanging the cation, that is calcium or magnesium, the sodium the H plus and OH minus will be at the end. So for this reason we have to charge it by using 10% solution of HCl for cationic exchanger and 10% solution of NaOH for anionic exchanger. So these two solutions, with solution of HCl and NaOH, will work as an anionic exchanger. Okay, so these are the two steps we have to take to make hard to soft water. Any confusion? Promit, you could not understood the method?